Welcome to part 2 of our Arduino bidirectional control example. In this video we're going to show you how to really affect bidirectional control between the Arduino and MakerPlot. And once again, it doesn't have to be an Arduino. It could be any controller like a pick, a pickaxe, a basic stamp, basic X, or any other microcontroller that can interface with MakerPlot. So let's get started by going to MakerPlot, and we have pre-selected the interactive interface. And once again, the interactive interface is a little bit different from the interfaces that we've been dealing with up to now, insofar as the controls really don't react to the analog and digital signals or mouse clicks like our other interfaces do. The interactive interface is really kind of like a virtual test bed for your microcontroller code to be able to determine how to interact with MakerPlot directly from your micro. And that's really an important point to make here, and that is MakerPlot has the ability to operate directly from your micro. As a matter of fact, you can put controls like this on the screen directly from your micro. That's a subject of another video, but nevertheless, you can do that as well. What I want to point out, as I did in the first video, is that each one of these controls has their own label to it. For example, this LED is labeled LED 3, even though the label below it is labeled LED 3. That label is really text LED 3. That's our text box indicating what LED it is above. The next LED is LED 2. Following that is LED 1. And then finally LED 0. And then coming down here we have 4 toggle switches. They are similarly labeled SW0, SW1, SW2, and SW3. And then finally, at least for this example, we have a slider here. And this is a typical slider that goes from 0 to 1,000. And depending on where you release the slider value appears here on the text box at the right. But notice the name, it is called slider. So what we want to do with the LEDs, the toggle switches, and the slider is to show you how MakerPlot can react to your microcontroller code to turn these controls on or off and interact with these controls, in particular the slider value. So what we'll do in our code to begin with is we will turn on each one of these LEDs and toggle switches individually, and then we'll turn them all off. And then we'll go to a portion of the program that allows us to use our slider to control our set point. And as you'll recall, the set point was normally controlled by the 2 push button switches. And let's take a look at a new graphic that kind of describes what we want to do in code before we get into that. And this is how our operation will now take place with our bidirectional control. First, we're going to send a command from the Arduino that says read the slider. So that command is going to go from the Arduino to MakerPlot. Then MakerPlot is going to respond to the Arduino with the slider value. And once again, the slider value can be anything from 0 to 1,000. And then what we're going to do in the code is set the set point equal to the slider. So in effect, we'll be able to now use the slider to grossly affect the set point value. And when I say grossly affect it, I mean the following. The 2 push button switches that we have attached to our Arduino, which are SW1 and SW2, are also part of this example. We're able now to adjust the set point not only with the slider, but also with these 2 switches that we used before. So we'll adjust the set point with the push button switches, and then we will send the new slider value back to MakerPlot. So we can adjust the set point with the slider, and then we can adjust the slider with the SW1 and SW2 push button switches. So now that you kind of have a mental image of what's about to take place in the sketch, let's take a look at the sketch right now. Here's a sketch we've used in part 1. Most of it is already described in part 1, so we won't re-describe that. That has to do with the setup where we stabilize the code, delaying 2 seconds, issuing a reset, and then issuing a minute button command to affect our time scale to be 2 minutes rather than be displayed in seconds. And then we put up our control from Arduino message in blue right across the screen. So that was already there in part 1. What's new in part 2 within the setup area is the following code. Right after putting up the control from Arduino message, we're going to delay 3 seconds. That'll give us time to swing over and look at the LEDs and toggle switches that we just talked about. And what we're going to do there is turn on the LEDs and toggle switches one at a time. And we'll do that by issuing the following commands to MakerPlot. We're going to issue a exclamation point capital O, LED 0 equal 1. Now notice this is an exclamation point capital O, not a 0, it's a capital O, and it's really short for exclamation point POBJ, which is our standard plot object command in MakerPlot. So this is kind of shorthand for that particular ubiquitous instruction that we use in MakerPlot. So an exclamation point O is an indication for the rest of the command to tell MakerPlot what to do. So in this case, we're going to use the label LED 0 and set it to 1, or basically turn it on. Then we're going to do the same thing with SW0, the toggle switch, and turn it on. Following that, we're going to issue the bell command to sound the PC bell, and that's just simply an exclamation point BELL, and then we're going to delay 1 second. Now we're going to repeat the process 3 other times for the 3 other LEDs and toggle switches, LED 1, SW1, LED 2, SW2, and LED 3, SW3. And finally, what we want to do is use a wildcard symbol to turn off all the LEDs and all the switches at once. And that wildcard symbol is an asterisk. So if we issue an exclamation point capital O LED asterisk equals 0, that will turn off all our LEDs. Similarly, if we issue an exclamation point asterisk equals 0, that'll turn off all the switches, we'll sound our bell, and we'll delay 1,000. Now this is a part of our setup code that's only going to happen once, and we only want it to happen once because I just want to show you how you can actually control the controls on our interfaces using microcontroller code like we're doing here in our Arduino. And there are numerous other examples that we can show you about this, but nevertheless, this will be kind of dramatic to see. So it'll happen once, and then we're going to get into our loop. Now our loop has been modified a bit to, first of all, read the slider. So we're going to do a serial.println read slider. Actually, it's going to be a serial print line exclamation read slider. So the read exclamation read is an instruction of MakerPlot that says read the slider. So we're going to read that value from 0 to 1,000. And that's going to go into the Arduino's UART. And then we're going to extract that value from the Arduino's UART with the serial parse int instruction. and we're going to set that value to our set point. So in effect, every time through the loop, we're going to read the slider, and that's the interactive part. We're now getting in here to MakerPlot and actually reading something that's on the screen that we can manipulate manually ourselves on MakerPlot. Remember, we were manually interacting with the slider using the mouse. So as we move the slider back and forth, we're able to read it, and we're all able to bring it into our Arduino code here. So we'll be affecting the set point using the slider with these first two instructions. The other instructions are similar to what they were in part 1, and that is we're going to test the sensor value against the set point, and the sensor value in this case is the potentiometer value. We're going to test it against the set point, and if it's above the set point, we're going to snap the screen. We've already discussed this in part 1. If you haven't viewed part 1, please do, because all of this is explained there. What's new about part 2 here is we're going to come down to the test statements for push button SW1 and push button SW2 on the Arduino. And that is, if push button 1 is depressed, meaning that it's 0, we're going to increase the set point, and we did this in part 1, but now we're going to add the following 2 lines of code. What we're going to do now is, as the set point has been increased, we're going to send the set point to the slider control to affect the slider control itself. So if the set point is increased, we're going to do a serial print exclamation capital O slider equal whatever the set point is, and we're going to follow that up with a serial print line to delimit our instruction. Similarly, if SW2 is pushed, we're going to then decrease the set point and send that information to the slider. So if you look at our code now, coming back up to the top of the loop, we're going to be reading the slider and adjusting the set point to whatever the slider is. And then if we come down here and we manipulate the push button switches, we'll be able to fine-tune the slider value to whatever it is we want it to be. Let's take one more look at our graphic, and that is we're going to send out a command to read the slider. MakerPlot is going to respond with the slider value. We're going to set the set point equal to the slider value, and then if our 2 push button switches are adjusted, we're going to then adjust both the set point with those switches, and then we're going to send that new set point value as a new slider value back to MakerPlot. So this will be an interesting example to show you, and let's do that now. We're going to begin by coming over here and clicking on our rocker switch. There's our message, control from Arduino. There were our LEDs and toggle switches that went on one at a time and then all turned off. And as we can see on our plot, we have the first 3 lines. These are our digital values. The top value is whether the set point has been exceeded or not. Right now it is a 0 and it hasn't been exceeded. The other 2 values are the decrease and increase push buttons, SW1 and SW2. The red line is our set point, and our black line is the potentiometer value. Coming over here to the right, we notice that our slider is set at 682. So let's change that. Let's just move our slider with our mouse. There it is. It just went down to 455. We can move it again up a bit. Went to 591. Move it some more. It's 807. Move it some more, and we're back to 511. Now coming over to our push button switches on our Arduino, we can adjust that value. So I'm depressing SW1, and as you notice, the set point is increasing slowly. The depression of SW1 is reflected in the digital value of the bottom three digital lines. Coming over to SW2, we're going to decrease the set point a bit, and you can see that happen digitally on the middle line. And looking at the slider value is changing accordingly. So let's do a couple of tests with our potentiometer. We'll move our potentiometer through the set point, take a snap, and as you'll notice, our set point digital line went from 0 to 1. Going below the set point, it goes from 1 to 0. Going above the set point, we took another snap. And going below the set point, it goes from 1 to 0 again. Okay, let's change our set point, move it up a bit. Go through it again. And let's take a look at our snaps. Come down here to View Snap, click on it. All right, that is the last snap that we took. We use our arrow keys at the bottom here to be able to look at previous snaps. That was the one just before it, the one just before that, the one just before that, and the first one. One last thing I want to show you is the log debug immediate window. And that is, as we see here, we see a lot of rapidly moving data coming through the log debug immediate window. Now as we move through the set point, we see a few things happening. Let's disconnect from our Arduino and kind of go back and see what happened. As you'll notice, as we went past the set point, we issued a snap interactive interface, which snapped our interface. Then we have the analog and digital values that are being sent. The first two right below that are the analog values for the set point and also for the pot control. Then following that are the digital values for the set point and the other two push button switches. And then here's our read command, reading 648. And then that's followed again by the analog values, the digital values, and the reads. So the log debug immediate window gives us a real-time view of exactly what is happening between MakerPlot and the micro. So please consider using the log debug immediate window a lot in your debugging efforts. So this concludes part 2 of our bidirectional example, and we'll have more to show you in other videos on how you can use MakerPlot to do bidirectional control with your microcontroller.